All right, really quickly before we move on to the next example, I just wanted to show you the graph of the last one that we just were doing. So here it is. I graphed it in Desmos, and we found, remember from our first derivative test, we found out that it was decreasing, then it had a critical number where f prime was not differentiable. That would be that little point, this little point right here. Then we found it was increasing, and then it had a relative max at 0, at x equals 0 has a relative max, that goes right there. Then we have, it's decreasing, we have a relative min, and then it's increasing again. And so this really, if you, you wouldn't normally have a calculator for these, so this is something that you would be not be able to just like look and say, oh look, it's increasing and decreasing. But you can always check, which is really great. Once you figure it out, you can check and say, okay, I figured out that it should be decreasing and then have a min and then be increasing and have a max. And we can look at all of these points, and sure enough, it's at -3, 0 like we thought, and +3, 0. And then this is at 0, 4.327, which I believe is -9 to the 2/3. Yeah, so there you go. That is, that doesn't seem right, because, anyway, we're not going to worry about it. Oh, it is. Huh. I was like, man, it does not seem right, because it's -9. But it's squared, so that makes it positive. Okay, so there you go. That is what the graph of that one looks like. So let's take a look at the other, at the next ones. Okay. So, let me see if I can get this to show me, or I'm not, probably not. Okay, so let's look at the next one. So, we're trying to find the relative max and mins. We're trying to figure out if the function is increasing or decreasing at different spots. So, the very first thing we do is we find any domain restrictions, okay? So, we find that the domain x cannot equal 0 on this one. Why? Because the bottom, if you put x equals 0 into this one, the bottom of this fraction is going to be 0. So this has a domain restriction of x equals 0. That means the function does not exist. In fact, we also know, because we know this, that that's a vertical asymptote. There's a vertical asymptote at x equals 0. Okay? So, number 2, the next thing we do is we find all of our critical numbers. So remember, our critical numbers are where f prime of x is 0 or undefined. So we have to find f prime of x first. So low d high minus high d low, square the bottom, and away we go. Okay. So that's a pretty complicated derivative, so let's go ahead and simplify it and see what we get. So we get 12x to the 4th minus 3x to the 4th minus 9 over 9x squared. And then we are going to simplify that some more. So 12x to the 4th minus 3x to the 4th is 9. X to the 4th minus 9 over 9 x squared. Those can all be divided by 9. So we're going to have x to the 4th minus 1 over x squared. Okay. So that's our derivative. Our derivative is x squared to the, or x to the 4th minus 1 over x squared. So now remember, f prime of x is equal to 0 when the numerator equals 0. F prime of x is undefined when the denominator equals 0. Okay, so those are the two things that we're going to check. We're going to find where is it equal to 0, where is it undefined. And so, where is the, let's see, f prime of x equals 0 when x to the 4th minus 1 equals 0. So let's figure that out. So that's x to the 4th equals 1. And we take the 4th root of both sides, and we find out that when x equals plus or minus 1, f prime of x equals 0. Because I could put a positive 1 in there or a negative 1 and still get out positive 1. Okay, so this is one of our critical numbers. Now let's see, where is f prime of 0 undefined? So we know f prime of 0 of x is undefined when 9x squared is equal to 0. So, yes, okay, let me make sure I was on the right path. Okay, so that is when x equals 0. So here's my this is my monkey wrench that I'm throwing in here. Is x equals 0 a critical number? Well, f prime of x is undefined. The derivative is undefined. But here's the monkey wrench. What else is undefined? Our function is undefined at 0. So, x equals 0 can't be a critical number because our function doesn't exist there. So remember, for it to be a critical number, our function has to exist, and the derivative has to either be equal to 0 or undefined. So since our function doesn't exist there, our derivative, it's not a critical number, okay? So, we could just say, not a critical number because f of x is undefined at x equals 0. This is a good thing for you to write when you're doing a test so that you can communicate to me and then eventually to the AP readers what you're talking about and why it's not a critical number, why you didn't use it as a candidate. Okay, so now we're going to make our f prime number line. And what you're going to remember is we're just trying to figure out what the function is doing at different places, so we're going to look at what the derivative is doing at those places. So we use all of our critical numbers and all of our domain restrictions. So our critical numbers are -1 and 1, and our domain restriction is 0, and I'm actually going to draw like a little kind of almost like an asymptote there because it's a domain restriction. So I just want to remember that that's a domain restriction, not a critical number, just so that I can kind of keep track of what I'm doing here. Okay, so let's figure out what's going on either side of this. So let's figure out what f prime is doing at -2. Okay, well, let's just I'm just going to copy back down f prime down here so that we have it. F prime of x equals x to the 4th minus 1 over x squared. Okay, so f prime of -2 will give us something on the other side of -1. So that gives us, this is a big positive number like 4, yeah, 16. I know that in my head. Great. Okay, so that's 16 minus 1 over 4. So this is going to be positive, this is going to be positive. So on the left side of 1, it's going to be positive. Then in between -1 and 0, we could put in 1/2. And we would find, let's see, f prime of 1/2, -1/2, would be 0.5 to the 4th, gives us like 0.625 minus 1 over 0.5 squared. Okay, well, that's going to be negative on top and positive on bottom. So it's going to be negative right there. And then let's check positive 1/2. So we're just checking in between each of these intervals what's going on with f prime. At f prime of 1/2, we get 0.0625 again because positive 1/2 to the 4th is still that, minus 1 over 0.5 5 squared. So we're going to get a positive, negative over a positive again. So, spoiler alert, that's a negative. So 0 doesn't actually, it doesn't change signs on either side of 0, which is really interesting. Because just because it's a critical number or a domain restriction does not mean that it's a relative max or min. That's why we do this. Because otherwise, you could just find all the critical numbers and be like, bam, relative extrema. But sometimes we have functions where their critical numbers and domain restrictions are not relative extrema. So last but not least, let's find what's happening on the other side of 1. So we're going to do f prime of 2, which is going to be 16 minus 1 over 4, which is again going to be a positive over a positive. So it's positive here. Okay, so let's see what that actually means. So all of that algebra is just to give us a good picture. And I know it seems kind of clunky, and it seems like, oh, I don't need to do that. You do need to do it, because otherwise you're not going to be able to you're not going to be able to remember everything that's going on all the time. And don't take that as a challenge, please. Don't take that as a challenge that you're going to I am gonna remember. Just, it's okay to write things down, and it's okay to write this number line down because it'll really help you. So let's look at what's happening in this function. So if f prime is positive, that means the function is increasing. So this is f, what's going on with the function, increasing. Then it's decreasing, okay? Then it's negative, so it's decreasing again. Then it's increasing, okay? So where are our relative extrema? Well, remember, we have a local minimum when f prime changes from positive to negative. We have a local min when it changes from negative to positive, okay? So our function is decreasing, 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 decreasing. Oh, changes to positive, and now it's increasing. So this is going to be a min. And then we have a maximum where it changes from positive to negative, right? Where it's increasing, 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 and then suddenly decreasing. So this is a max. So what are these points? Well, let's figure them out. So our max is at x equals negative 1, and our min is at x equals 1. So let's calculate those. And again, then we're going to use our function because we're talking about what's actually happening on our function, not happening in our derivative anymore. So I'm sorry if that's complicated to figure out which one you're using. The more you practice, I hope the better you'll get at it, that you'll recognize that now we're looking at, okay, there's a maximum in our function, so we're going to plug it back into our function. So we're going to find f of negative 1, which is 1 plus 3 over negative 3, which is negative 4/3. And then we're going to find f of 1, which is 1 plus 3 over 3, which is positive 4/3. So our final answer on this one is that we have a max at negative 1, negative 4/3, and we have a, relative max, and we have a relative min at 1 4/3. Okay, so those are our questions. What's happening there? And then it also says find the intervals where it's increasing and decreasing. So if we look back here, from negative infinity to negative 1, it's increasing. So I'm going to write that in here. Okay, so it's increasing from negative infinity to negative 1. And we're going to have open brackets on these because it can't be increasing at a point because it's actually stopped at that point. So it's increasing from negative infinity to negative 1, and then again from 1 to infinity. Then it's decreasing from negative 1 to 1. Oh, I am not right. It's decreasing from negative 1 to 0 and 0 to 1. Do you know why? Because it can't be decreasing where it's not defined. right? That's an asymptote. It cannot be decreasing at that place